Excellent. All right, hey folks. My name is Cian Clarke. I'm a software engineer with Red Hat Mobile. I was one of the original engineers who was building what was once Feed Henry, now known as the Red Hat Mobile Application Platform. So we were bought by Red Hat a year and a half ago, almost 2 years ago now. And the Red Hat Mobile App Platform is Red Hat's mobile solution. We're going to talk about it a little bit today. Tell you guys how you can get your hands on it. We're going to do a demo. We're going to do a little live coding. Hopefully stuff doesn't break. We'll see how it goes. I wanted to highlight a couple of the other mobile sessions that are happening today. The first is mobile microservices and containers. Fantastic session with some kind of first-hand experiences on building, using containers with the platform tomorrow, Tuesday. And I believe one of the presenters is in the room. John, put your hand up. There he is. Cool. Apps 101 on Tuesday as well. Thankfully not conflicting with John's session, so you can come to both. I'm going to be doing a lab on building mobile apps and microservices for beginners. So it will be a pretty entry-level, entry-level kind of coding. You can go a little bit further above and beyond if you want, but it's going to be a lab. There'll be machines that you can all use, and you'll get to have some hands-on time with the product as well. Electronic Arts are giving a presentation on Wednesday about developing the intersection of mobile microservices, Node.js, and DevOps. Really cool session about their kind of experiences with the platform. Easily exposing legacy systems to your mobile apps, common concern. Everybody hates having to deal with legacy systems. That's happening on Thursday. And lastly, also on Thursday at 4:45, I've got another session with John again. Mad for Mobile, achieving mobile Zen through agile DevOps and microservices. So now that I've plugged all the other sessions, here's what we're going to do today. So we're going to start with a couple of slides, and when I say a couple, I mean very, very few. In fact, I've got 3. Then we're going to go to a demo, and we're also going to look at an example solution, and that's where the live coding is going to come in. We're going to see how we would actually go about building a solution on the platform to integrate with another backend. So first of all, I wanted to talk a little bit about why you might want to consider an application platform, set the stage a little bit, and I promise this is literally one of 3 slides, so we'll get through this pretty quickly. So import when, I believe that's supposed to say important, when dealing with multiple applications, building more than one app within an enterprise, it's always difficult to figure out where stuff is being built, where's the source code and so on. And so that's why companies often consider using some sort of platform. Likewise for mobile development approaches that may differ, maybe there's a native app being built. Sometimes people will build native Android, native iOS. Sometimes people will build hybrid apps. Being able to bring some sort of cohesion to that kind of different development methodologies is quite important. When building for multiple mobile phone form factors, so things like tablets, phones, watches, who knows what's coming next, right? Also developing against multiple backend systems. So we'll see how we can expose backend systems in this kind of reusable way across the organization and bring some sort of kind of common front end to the different backends the companies need to integrate with. Anything from JSON web services that exist in a corporation, if any, to SOAP, to some funky FTP server integration. There's all sorts of possibilities for building mobile APIs that speak one cohesive protocol to the mobile device, and the platform helps with that. Another thing is third-party developers, third-party companies building apps on a platform. A big problem that organizations have is as people are screaming out and looking for mobile app development, they will have some sort of third-party agency build the application for them, which is absolutely fine. But if this third-party organization has not sent over the key pair that the app was built with, or not sent the source code of the application, that's a real problem for the organization that's hired this contracting company. And if they can't get at the source code of their application, what exactly have they paid for in the first place? So a platform is another great way of kind of bringing some cohesion into that story as well. So this is the platform in a diagram, essentially. And it's split up into 2 parts. On the right-hand side is what we call the core. And it's where we do things like lifecycle management for the development process. There's a private app store, there's analytics data, unified push stuff. There's some user management, both for the people developing the apps and also the end users of the applications as well. There's this concept of teams, where you can select the kind of dev teams that have access to what components of the studio. We'll see all of this in the demo. There's also some app development functionality which helps boost developer productivity. So things like templates, there's a forms builder which we'll see, there's tutorials and documentation, a place to manage credentials. I mentioned the scenario earlier of losing that key pair used to build the app. There's a place to store those. And also a build farm, a way of building mobile applications in the cloud and returning a native binary without having to run native Apple hardware or run a Linux build box. So even people using a Windows machine can generate Apple builds and can generate builds for Android and so on. So that's all living in the core. And then there's this other part called the MBaaS as well. Now this MBaaS is kind of interesting because this is where all of the kind of sensitive data flows for the application. So this is where you would do integrations into backend systems. Maybe you've got some ESB somewhere, or you've got some SOAP systems, and you've got sensitive data sitting behind those systems. Maybe it's even behind a firewall. Maybe these systems aren't public to the outside world. And that's why this MBaaS part is developed so that it can be delivered either running in the public cloud, or it can also be deployed on-premise. And we'll see an example of that later as well. And so what's flowing through this MBaaS is things like the sensitive data that lives in these enterprise backends, the data caching, data synchronization. There's a microservices layer, which we're going to build one of in a minute. And all of this sensitive data living potentially behind the firewall is really important because it means you're able to meet things like data sovereignty laws and so on and so forth. So another thing I wanted to highlight today is you can try this out yourself. Now in the lab session that we're doing, you'll get a chance to actually try this out yourselves with some guided tuition. But if you want to, in your own time, play around with this product and make use of it yourself, you can do so. 3 simple steps. You need an account from Openshift, so openshift.com, register for an account. Then openshift.feedhenry.com, press the request and invite button, and then you'll get emailed a link, which is your invite to make use of the platform. So 3 simple steps to get up and running with the platform, and you can try all of what I'm going to show you today yourself as well. And now it's demo time. So I told you the slides would be pretty brief, so we might as well get stuck in. And I'm going to bump the font size a little bit. Hopefully everybody down the back can see that okay. So this is the Red Hat mobile application platform. Since I'm in full screen mode, it might not be obvious, but I'm running this in a browser. This is browser-based software, and I'm here on the home screen. Now I'm logged in as a kind of privileged user, so I have access to every part of the system. I can, look at the projects. I can look at the back-end integrations. I can look at the resource usage, the analytics information. But all of this can be locked down to individual development teams. And we'll see an example of this later and how we would go about setting this up. Just know that everything I'm showing you today is from the point of view of the power user who has access to everything. So I'm going to look at this project screen. And projects are these concepts within an organization that we're trying to mobilize. So things that we've got a mobile initiative running for. Now projects might have development teams that are building the applications in-house. It might be an external development company. Maybe even components of the individual product are being sent out to development companies. So it could really be anything. I've got a couple of example projects here. I'm going to look at one in particular, this Birdhouses Inc. project. And it's a bit of a tentative example. It's this idea that there's a traveling birdhouse salesman who needs to build an application for his organization that takes into account orders, stores the orders in a database, and then ships them out to the Salesforce contact associated with the order, and also looks up inventory in SharePoint as well. Why birdhouses? I don't know. It was just some ridiculous example. And so we've got this 3-column view which sets up this scenario. And on the left, we have the client-side application. In the middle, we have this cloud microservice specific to this project. And on the right, we have these MBaaS services which are reusable throughout the organization. Now, I'm going to talk a lot more about the middle and right-hand column in a minute. But for now, I want to take a look at this ordering app on the left. So this is the client-side application, which actually gets installed on the mobile phone device. In this case, it's built in HTML5. And because it's HTML5, we actually see a preview of it over here on the right as well. So I can interact with my application. I can resize the preview. I can change the mobile phone device. And I can even click around in here as well. Now, because this is a HTML5 application, we can also take a look at the source code here, and we see that we have HTML, JavaScript, and CSS. So this app is built using standard web technologies. It's using Cordova in the background, by the way, for those of you familiar, what was once known as PhoneCap. And I can go ahead and make changes right here in the browser if I want. Kind of useful for quick changes or to make sure that something was checked in or so on. But really, does anyone want to use a web-based IDE right now? Probably not. I think people prefer to use their own tooling. So we also allow you to clone the application onto your own computer using Git. And I think that's really important. So you can Git clone this application, either using the command line or using one of the many GUI-based Git tools. Some IDEs even have Git built in. And then you can make changes to the application in Xcode or Eclipse or Vim or Emacs. We don't judge. Whatever you want to use is fine. I can also view analytics information for this app. Now this is sample data, so I guess this pie chart probably is no longer accurate. I can see how many installs the application has had across a number of different platforms. I can see by location as well, which is pretty cool. And I can even filter this information by date range to be in the last 7 days, the last month, on a specific day, whatever the case may be. So this is like a really useful kind of at-a-glance view of how the rollout of mobility is going in an organization. And it's a great way for people who are building things like a mobile center of excellence to justify this kind of spend in mobile and to see whether they're actually having any success and traction in their mobile initiatives. So that's analytics. We've got this config section as well, and this is where that kind of per platform disparities live. So things like when you're building a hybrid app, one of the common challenges is some config settings don't map between Android and iOS and Windows Phone. So for example, on Android, we have this concept of permissions, and we need to ask for the user's permission to use the contacts and the camera and audio and so on. So that's where these kind of individual disparities are mapped. And all of the common stuff is handled up here at the top in the detail screen where we can set things that are common, like the app which has a name, the name that appears in the home screen and so on. We can also configure push notifications for our application. This was done by embedding a community project within Red Hat called AeroGear, which some of you might be familiar with. And it's now bundled into the product and allows you to do push really, really easily within your applications. All you need to do, in fact, is register with the Google Push Console or the Apple Push APIs, and then it's practically a button click to get up and running with push. Now, what's really nice about this is right here within the App Studio, you can send a push notification to your application. You can type in some message. You can select the variants that you're going to be pushing to. You can send the push notification, and then you can view how the push is being rolled out between applications and see how many applications have actually received this push message as well. So really nice to have this built in. We can build the application as well. So I mentioned earlier that there's this cloud-powered build farm, which means that we can build the application right here in the browser without needing to run Android Studio, which isn't too big of a deal because we can run Android Studio on a Windows machine, on a Mac, on a Linux box, but we can also build for Apple. Now that's a little different because, as many of you probably know, to generate Apple builds, we need to run on native Apple hardware. We can't go ahead and generate Apple builds on a Linux machine or on a Windows machine. So it's really nice to be able to do that right here in the browser rather than having to hand out expensive Apple hardware to all of our developers. You'll notice I also have the option here to integrate with MDM. It's mobile device management, if that's been rolled out in my company. So I can push from this build farm right into the MDM provider. In this case, it's Aperion. I think there's support there for Mobile Iron and AirWatch as well. And all I need to do is configure my username and password, and that will push that built binary into the MDM catalog for distribution. So I can go ahead and build this application. And what it's going to do is it's going to take that HTML, JavaScript, CSS, all of that source code you saw earlier, and send it out to the build farm, which is going to run it through the Android Studio command line tooling, and return back to us an APK file, a built APK file that I can run on the device. Once it's complete, I'll get a QR code and a short link to install the application, and I can copy this into an email. I can download the APK file and attach it. I can upload it to SharePoint. I can upload it to anywhere, really. And this is a legitimate Android binary, and if I was to scan this QR code, it would install on my device. I'm going to close this window before everybody in the room suddenly installs it and ruins my demo. That has happened before, by the way. Another thing I can do with my application, So of course I can get the app source code out using Git, and I can clone the application down onto my computer, but I can also export the app's source code as an Android project or as an iOS project as well. So there's no kind of vendor lock-in here. You can see exactly what's going on under the covers and get that native project and generate your own builds if you want on your own machine to see exactly what's happening under the hood. And that can be useful for debugging build issues or for debugging issues on the device. I'll quite often export the iOS project and do the web inspector to see exactly what's happening within the application. So really useful to be able to get the source code out of the platform as well, not just as source code, but also as a native application project. I can upload credentials for this application, so things like that Android key pair that I talked about earlier, because a lot of people don't realize this, but if you lose your Android key pair, you lose your ability to update the application in the App Store. So if you've got an app in the public Google Play Store that you developed 3 years ago, and all of a sudden you've lost that key pair file, you're in real trouble. You've got no way of updating the app, and that's a bit of a pain, as you can imagine. So really nice to have a place to store this, and it might not seem like the most important thing, but it turns out that it often is. So that's the client-side application. Now I've talked a lot about HTML5 and about how this is a HTML5 app. But what if we've got a native app? What if we're building for iOS or for Windows Phone only? What if we're building a Xamarin app or an accelerator app? And one of the important things one of the kind of key takeaways here is that the platform is client-side agnostic. We don't force people to use, HTML5, JavaScript, Cordova. You can import an Android app. You can import a native iOS app, Xamarin, Accelerator. And then there's a couple of framework examples as well, like Angular, Ionic, Backbone. But really, you're free to make use of any sort of client-side tooling you wish. Especially if it's JavaScript-based. There's so many frameworks here, but native as well. If you're building a native app, we've got CocoaPod support in the platform. You can bring in native iOS dependencies and have those built. So it's a really rich environment that allows you to do an awful lot on the client side and develop apps your way, rather than this kind of prescriptive, here is how we want you to build your apps kind of approach. So I think that's really refreshing. So I talked about the client-side application a lot. Let's talk a little bit about this cloud layer now here in the middle. So we have this mobile microservice. And this is where we put the project-specific logic. So stuff which is only relevant to this particular project that probably won't get reused again in future. Whereas over here on the right, we have the reusable logic. So what's the difference? Well, sometimes, quite often, you'll just pull data from one of these reusable services, and you'll do very little in here. But in this case, the scenario was somebody out in the field makes use of the ordering app to place an order. The customer who's buying the order is looked up in Salesforce. The product inventory is looked up in SharePoint. And then the order is put in a separate database. And this is a database connector here. So a pretty kind of complex operation. And we absolutely could have built this integration on the client side and have the mobile client talk to these 3 different services disparately and know all about what SharePoint looks like and know all about what the Salesforce API looks like. But that's a pretty messy approach. I don't know if anybody's ever had to integrate with SharePoint before. It's a little tricky to say the least. Not a pleasant experience. And the API is quite chatty as well. It returns a huge bulk of data that might not even be relevant to the mobile application. So what we've done here is we've created this mobile-specific API, this one cohesive API that the mobile device talks to into these back-end systems. And it kind of abstracts the idea that the mobile device is making use of Salesforce to store the contacts or using SharePoint to store the product inventory. And all the mobile device knows is that there's a REST API out there that it talks to that's able to communicate with these 3 different things, but it doesn't even know about that. And what's also quite cool is as I'm building this project-specific logic, which mashes up these 3 different services to make one cohesive API, I'm able to discover the different integrations that are being used here. So I can discover the integration into Salesforce, and I can try it out right here in the browser. I can try my login, get back a token, pass that token into the accounts or the cases API, and so on. So a really, really powerful way of building integrations. And we're going to look in a moment, by the way, at how we actually document one of these services to make it discoverable. We're going to make an interactive example of a service, and we're going to make it with a weather service rather than with Salesforce or SharePoint. So if I open this middle logic, this reusable mobile app here, the reusable microservice in the middle, I can see that my cloud app is running. That's great. I can see the host name of this application, because this is just a REST API at the end of the day. There's no kind of black magic under the covers that's hiding what's going on. It's a REST API that the mobile application talks to, and there's a security layer there, and there's a lot of nice added value, things like being able to see statistics for your endpoints and so on. But at the end of the day, it's a REST API. There's no funky RPC calls that are proprietary to Red Hat. It's a REST API, and it's really easy to debug. We can see the source code for this API. And I should mention this microservice is written in Node.js. So if I open application.js, I see JavaScript. By a quick show of hands, by the way, how many folks in the room have done something with Node before, with Node.js before? Quite a few. OK, cool. Excellent. So we see this Node.js application. We can see the API that we're exposing. We're exposing one route here. I'm going to dig into this route a little bit more when I start coding. And as before, we can clone this app down into my own computer as well. We can add things like environment variables. We can use the data browser to see what's living in the database. And we can deploy the application as well. So that's that cloud application. And it's a bit like a PaaS layer, if anybody's familiar with PaaS technologies of old. But it does a little bit more on top of that as well. And I'll dig a little deeper into that in a moment. So we've talked about the middle layer. We've talked about these reusable services and how they get mashed up here in the middle. These services, by the way, look very like this mobile microservice in the middle. They're also Node.js processes. This is an off-the-shelf connector. This is off-the-shelf. We can also add in here custom connectors. This is just a custom database connector. What's worth mentioning as well is these reusable services that we've stand up here that are off-the-shelf. Yes, they're off-the-shelf services, but the source code's right here. So you can go ahead and clone down, for example, the SharePoint connector and make your own fork of it. You can make some changes. You can add some functionality. And in fact, if you're feeling particularly generous, oops, sorry, I didn't mean to go here. If you're feeling particularly generous, you can even contribute back to Red Hat the changes that you've made. That's how this works, right? And that's actually happened with the SharePoint example. So we've got our SharePoint connector with quite a few contributions from a Red Hat customer as well. So it's really nice to see that happening. So I've talked about these three columns. Let's change gears a little bit now. So what I wanted to do was kind of expose you a little bit to the other functionality of the platform, the drag and drop app functionality. Now, when developers hear this idea of drag and drop apps or rapid mobile app development, they typically recoil in fear. And sometimes, I mean, quite rightly so. You've got this idea of the silver bullet and no longer needing client-side developers. And I think we probably all realize that kind of utopia will never really quite be reached. So I wanted to show you the forms builder. But what I think is really cool about these forms, so they're built with drag and drop. And I'm going to go ahead and create a new form here, a blank form. I'm going to give it a name, my new form, some description. I'm going to create, and I get this blank canvas, right? So it's a form that I can build into an application, and I can drag and drop form fields. So I've dragged a text field, a paragraph field, a number field. Pretty cool. I can change the name of the fields, enter your name, and it's not just text, by the way. There's quite a bit of richness as well. I can add things like barcode capture, signature capture. And what this is doing is it's kind of transforming what would have traditionally been a paper-based process. Fill out a form, and then later on, somebody in the back office fills out all of this data into the system by typing it all manually. Really, really inefficient. It eliminates the need for that and allows companies to very rapidly develop a form with a very rich mobile experience behind it that captures all of this data in the field right at the point of entry, or right at the point of capture, I guess, and brings it right into these back-end systems as well. And it's not just doing that, because it's also adding some richness to this with things like barcode capture, something that you can't do with a piece of paper, or indeed with location as well, a really nice, rich way of capturing information that's available from smartphone devices that wouldn't have traditionally been possible. Likewise with photos. And we had scenarios where people would be like writing out grid references or latitude and longitude references from a handheld GPS unit on a paper form. So you can imagine the types of efficiencies this can bring. And once I'm finished designing my form, I can preview it over here on the right. I can save a draft of the form, and I can fill out the form here as well. So it's a really neat way of mobilizing a form really quite quickly. Now I talked about how this form was built using DragDrop, and I can go ahead and embed it into an existing project. And I'll show you an example of that now. Forms project. So I can use this off-the-shelf project to build my forms, which is really useful for managerial users who don't want to involve a dev team for something really small. So we can preview. That's actually quite small. Let me make that a little bigger. There we go. So we can preview this form over here on the right, and this is, of course, what it would look like on the device. And we can interact with the form and so on. And we can build this form without having to do any sort of coding, any sort of manual work. We can use the build farm to generate the form and install it on our device. And that's fantastic, right? But that doesn't cover every possible scenario. And what I really like about the forms functionality, this drag and drop forms functionality, is you can embed these forms into existing applications as well. So there's a whole SDK behind this form functionality, which allows you to take a form, render it into a container, be it an in-app browser for a native app, or just a piece of HTML on the screen in a hybrid app. So you can take these forms and bring them into your existing apps as well. And I think that's important because being able to build drag and drop forms is a really useful piece of functionality, but it's also important to know that it's so expansible that you can bring it into existing projects and front it with a login screen, which maybe associates the submission with some user in the back end, add security to the form submission, and so on. And not just on the client side. So I talked about how you can embed this form into your existing app. You can also use submission events to take the submission and throw it away into another backend system as well. Maybe it gets back into a system of record. So really, really powerful stuff. So that's the drag and drop form functionality. What I wanted to do now was shift gears a little bit and move into a more practical demo. So are people ready for a little bit of live coding? All right. Appreciate the enthusiasm. It's always good to have people look forward to me, fail right here in front of you. So always a bit risky, but anyway. Let's go ahead and create a new project. And we're going to start out with the simplest kind of example, this Hello World project. We're going to call it Weather Demo. And so what this is going to give us is a cloud app and a client app. I'm going to hit Create. And it's going to be a really simple project. It's going to be a Hello World template that we're going to start with. And what I'm going to do is I'm going to take the client side. Actually, we're going to start with the service side. We're going to take this Node.js microservice. We're going to do a really simple integration into a backend system. We're going to pull back some weather data, and we're going to mobilize it to the mobile application as well. I'm going to click Finish. And so we see on the left that we have the Cordova Lite application. This is this HTML5 app. And in the middle here, we see the cloud app as well. So to get started, I'm actually just going to kick off the deploy and save a little time later. And I'm going to deploy this 2 different places. And now that that's done, let's go back here. So what we're going to do is we're going to integrate, like I said, with another weather API. And to do this, I need to find an API, right? Now I've got this really cool tool that I discovered for finding APIs. It's super discoverable, very interactive. It's got a natural language API. It's called Google. And I can just type in JSON weather API. And what do you know? I find a weather API. So this is the Open Weather Map API. It's probably people's de facto standard for demos. So if people have seen 1,000 weather demos already, I'm sorry. And we're going to go ahead and look at the API docs for this weather API. And we see we call it with a query string for London, UK. Now what I used to do is I would just take this weather service API and I would type into Google JSON weather API and I'd find it and I'd make use of it. And it turns out that if you look in the address bar, embedded here is the API key. And so their examples actually had an API key in it, and I thought I'd be really clever and take their API key. And then that expired, and this started happening. And all of my examples were broken. So I actually had to go ahead and register for an API. Not sure why we're losing. I should have really plugged in my laptop. Ooh, that's not good. Okay, let's all cross our fingers. So what I did is I went ahead and registered for an API key. And now I have this, this open weather API that I can access using my API key. But I need to, I'm not sure why this keeps dropping. Interesting. So I've taken note of the API key, and I'm just going to copy it onto my clipboard so that I can make use of it later. So in this new project that I just created, I'm going to jump into the cloud application, and I'm going to make use of the editor to write a little bit of code. And you'll notice that this is a Node.js app. So in this application.js file, this is where I define the APIs that my app uses. Now, it's an app that uses Express.js, the Express framework for building REST applications. And I can see that there's actually one route here, this hello route that we're going to build upon. Most of this is boilerplate, by the way. It just sets up the server, integrates the feed Henry middleware, which allows it to do some kind of introspection on what's happening. Likewise with this stuff. So really, this is the only route that we've added, this hello route. So we're going to open lib hello.js, which is where we define this route. And you'll notice in here that we expose two operations, a get and a post. I'm going to get rid of the post. And I'm going to change the get API. Can people see this down the back, by the way, or is it a little small? I can bump it some more, maybe. Let's try. OK, I think that's all we're going to do. There we go. Hopefully everybody can see this OK. So we're going to change the get API as well. And we're actually just going to bind it to every REST verb. So a little known fact in Express is that you can say something.all and bind to all of the HTTP verbs. And it's really for those who are super lazy about doing REST, like bad REST developers. So I'm going to bind to all the HTTP verbs, and hopefully you'll all have forgiven me by the end of the session. I'm just going to put the URL that we're using into a comment as well. This is the URL of our REST API that we need to integrate with. And so to do this integration, I'm going to make use of what has essentially become the de facto standard for HTTP in Node. We're going to require the request module. And we're going to make use of request to do our web request. So I'm going to do request. And into request, I'm going to feed a couple of options. So I'm going to give it the URL. And right now, I'm just going to paste in the URL as it was in that comment. We're going to do a couple of tweaks to this in a moment. So we're going to use the URL. And we're also going to tell request that it's JSON, JSON:true. Another nice feature of request, if I say JSON true, it automatically sets up the JSON headers on the way out. And on the way back in, it'll take the string and parse it into JSON that we can make use of right here. And by the way, one of the really nice things about JSON APIs in JavaScript, as many of you probably know from using Node already, is that it's a first-class citizen. So being able to make use of JSON objects in the language is really, really nice. JSON the whole way through the stack, both on the client side and on the server side, makes for a really productive development environment, I found. So we have the request. We need the callback function. The callback gets an error, a response, and a body. So you can tell I've used request once or twice before. It's almost like, I don't know, reflex now at this point to just type this. For anybody who hasn't done Node.js development before, by the way, you may have heard of a term called callback hell in relation to the language. And we've just got like 2 levels of callback going on here. But you can see why that becomes a concern. And there's, just know that there's ways to solve this problem if we need more and more callbacks. So don't get too alarmed if you haven't seen Node before. So what we're going to do here, I'm not going to be a lazy developer. I'm actually going to check for the error condition. And if an error happens, I'm going to return res.status. Well, OK, maybe I am going to be lazy, because I'm just going to return a 500. Since we know 500 is the only possible error exception anyone ever throws anyway, right? And we're going to send back the JSON with the body of the message. And we're hoping this doesn't happen. So instead, what we want to do is return res.json, the body that we got back. So this is good. OK, we've built a kind of a naive weather API that just blindly calls out for the weather in London, UK. Now let's optimize this a little bit. So the first thing we want to do, see this app ID? Let's pull this API key out of here. And let's put it in an environment variable. I'm just going to save the changes I've made here, file save. And I'm going to go to the environment variables section. I'm going to add an environment variable. called weather API, and I'm going to put in the value as well. I'm going to go ahead and push this environment variable to my dev environment. And you'll notice I'm able to set separate API keys for each of my environments, which is pretty nice, right? And so now we have our weather API key. Ooh, missed the value. Update, push. And so this is really useful when you're developing against different systems between dev and production, and you want to set up things like a staging server, a development server. Maybe your database instance is different between different environments. So it's really nice to be able to set environment variables on a per environment basis. So now in the editor, we're going to go ahead and in lib hello, we're going to pass in a query string, because that's all we were doing in the URL anyway, right? So we're going to pass in a query string for the app ID, process.env.weather API. So we're going to grab the API key, and I'm actually just going to default to the API key as well in case that doesn't work. So for those of you not familiar with JavaScript, all I'm doing here is using the kind of falsy evaluation with the OR symbol to assign this default if this doesn't exist. The only reason I'm doing that is because I'm going to deploy to another environment in a moment, and I want to make sure this works there as well. So we've got our app ID, and the other thing we're going to want to pass through is the location. And so we're going to make use of var location equals London, UK, and I'm going to get rid of all of that stuff from the URL here. Okay, now, why have I got this? Because I don't have a comma here. There we go. So that's great. We're calling the weather API. We're passing through our environment variable as our API key, and we're also passing through a location. But I'm originally from Ireland, and I'm not really happy with the default of London, UK. So first thing I'm going to do in a grandiose stroke of patriotism is set it to Dublin, Ireland. And I'm also going to take the location from the request as well, because we want to be able to pass the location from the mobile app. So let's do rec.query.location. And if it doesn't come in through the query string, let's take it from the body as well. Rec.body.location. And if it doesn't come in from either of these, let's take the default as Dublin, Ireland. OK. So I think that's all I need to do for this weather API. I'm going to go ahead and hit save. And then I'm going to go ahead and deploy my changes. Should be a pretty quick deploy because we haven't changed very much. And while that's happening, I just wanted to point out, oh, it's complete, good. I just wanted to point out that since this is a REST API, I can get the URL of this REST API right here in the browser. Let me just show the URL bar for a second. And I'm able to call this API because we defined a get route. And so we can go /hello. And hey presto, we see our weather response, which is pretty neat. I can call it from the browser, great. And we see what the weather looks like in our default of Dublin. Here we see Dublin. Let's go ahead and change it to be $location equals SF USA. We see in San Francisco the temperature is 302. Now, I was quite alarmed when I started looking at the weather in Dublin and saw it's 302 degrees and thinking, oh no, what's going on in Dublin? Is Dublin burning down? No, it turns out that the weather API is not in Fahrenheit, not in Celsius, but in? Exactly. So that, puzzled me for quite a while. The other interesting thing about this is we can see that there's a thunderstorm with light rain outside, and because we're in a dark windowless room, none of us knew that, so now you know. Glad to bring a little bit of a thunderstorm to your day. OK, so our application is deployed. I can try it out in the browser. That's great. But what if I wanted to, oh, that was unexpected. What if I wanted to try it out in the interactive documentation section as well? So this is a syntax called API blueprint. And this is how we write API documentation for our APIs in Red Hat Mobile. So it's quite similar to something like Swagger, if you've used Swagger before. I really like API blueprint because it's written in Markdown. And it's quite a sensitive syntax. It's sensitive to things like spacing and so on. But it's also human readable. And it's quite concise, which sometimes Swagger is not. So I really like the fact that this human readable API documentation can also drive this discovery console. So we know that in our request body, we take a thing called location, and we default it to Dublin, Ireland. Let's put Waterford, Ireland in here, since I see there's some of the Waterford, Ireland contingent sitting here. And I wouldn't want them to to think that I'm favoring a certain Irish city over another. I'm going to go ahead and save this change. And now if I go to the Discovery console, I can see my API. I can try it out right here in the browser. I can call it, and I can see the weather in Waterford, where there are broken clouds, although strangely it's not raining. I can see the weather in Dublin, where it's also not raining, and now I'm beginning to get worried. It's got to be raining somewhere in Ireland. Let's try Cork. No. What do you know? Limerick. OK, let's do Limerick. Yeah, it always rains in Limerick. Nope, scattered clouds. Galway. OK, this is getting ridiculous. Surely the West Coast has a bit of rain. Oh, for God's sake. Well, it's raining here, so that much we know. OK, so our API is now interactive and discoverable, and we can try it out in the browser. And this is a really simple example because I didn't change the root. It's still mounted under hello. I was just being really lazy. And all I really did was set up the location. Before I go on and make a change to the mobile application, I just wanted to show something here. So we can make use of this stats section to see the API in use. And we can see that we're getting 0.2 requests per second. And that's just me hitting the button in the browser to go ahead and call the API. So not a lot of usage. But imagine a scenario where all of a sudden this API is scaled up to thousands and thousands of users that are making use of this API. And something's gone wrong, and I want to see where the bottleneck is. So let's just simulate that scenario. I'm going to use my terminal window and a little piece of trouble called Apache Bench. Basically a denial of service attack in a box, which is great. Minus C, let's say 100 minus N, 1,000. I think that's the syntax. And we're going to call our weather API. So we're going to do 1,000 requests, 100 at a time. So we're going to generate some traffic, right? That's a pretty decent load. Nothing huge, nothing that's going to bring down production, but it should be enough to draw some pretty graphs. And you'll see our mean response time was 894, pretty nice, pretty quick API. So let's now refresh the statistics page, and we should see quite a bit more usage. And there we go. There's that massive spike. All of a sudden, we've got 85.4 requests a second. And we can look at the shortest and longest and the 90th percentile and so on. And you'll notice that this request stuff has been drawn just out of the fact that I put this middleware in here. And it's actually introspectively looking at the requests and drawing this graph based on that. So really, really nice. So now we've got our cloud app built. Let's take a look at our client app. The changes here are going to be really simple. We're going to go into hello.js. Instead of sending the hello, we're going to send our location. We're going to save. And in index.html, just to make it a little nicer, I'm going to say the placeholder text for the input is going to say enter your location. And the button is going to say get weather data. I'm going to go ahead and hit save. And now if I refresh the preview, we'll see our updated UI. I can interact with the application. I can get my weather data in Boston, MA, where I live right now. And I get onto find. Why do I get onto find? Because I forgot that in hello.js, I can no longer pick off a property called res.message. I need to look for, let's just take back the temperature. And let's also put in a warning, in Kelvin, don't panic, nothing is burning. All right, let's go ahead and save. I'm actually going to pop this preview out into a new tab to make it a little bigger. Looks like the save is hanging a little bit. Looks like my browser is hanging a little bit. OK, who's using BitTorrent? Come on. Own up. Yeah, I've got no internet. Well, that's a minor issue. Let's hope that it comes back. And in the meantime, I'm going to see if I can get this to work offline. So the other thing I wanted to point out, you'll recall earlier that I talked a little bit about how, where's that diagram gone? So I talked about how we have this concept of the core, and we have this concept of the MBaaS, right? And so over here we have all of the kind of sensitive enterprise data that lives. And this, by the way, can be deployed on-premise behind a firewall using what's called Openshift, a Red Hat product called Openshift, which you've probably all heard of. It's version 3 of Openshift, the latest version. Uses fantastic, containerized architecture. And I wanted to just show the kind of benefits that that brings. Because you remember earlier that I used Apache Bench to fire a big load at an endpoint and try and break stuff. Yep, lack of Wi-Fi would certainly cause that. Do I have signal? Maybe I could turn on a hotspot very quickly. Come on, LTE. Yes, love San Francisco. Okay. This is called thinking on one's feet. Come on, Verizon. Has the Wi-Fi dropped for anybody else, by the way, or is it just me? It works? Man, what did I do to anger the Wi-Fi gods? Yeah, that's right. We didn't do a live sacrifice before doing a live demo. I mean, all that live coding was going so well. Something had to break, right? No, I've got nothing. Oh, there we go. We're back. OK, good. So we were trying out our hello example here in the browser. I was changing this to be, OK, it looks like it committed. So I can go ahead and enter my location. Let's do SF USA, get weather data. No. OK, what would happen here is the temperature would appear in Kelvin, along with the text that I wrote, nothing is burning, don't panic. And it's really exciting, I promise. Like, there's fireworks and everything. It just didn't work, so sorry. We'll blame the Wi-Fi gods. Let's see if I can complete this part of the demo, and then we'll open up to questions. So the last thing I wanted to show you is that, oh no, really? Maybe I need to log in again, yeah. No, I'm still logged in. Come on. Yes, OK. This is what I wanted to show. So I've deployed my cloud application. It's running on OpenShift. I'm firing a bunch of requests at it. But all of a sudden, it's not scaling enough. And so before, this was a case of an operational consideration. We need to involve the operations team. Now it's really simple. So because this is running in OpenShift, this cloud application that's getting all of these requests from our thousands and thousands of users in the field, I can just press this up button and scale it up to 2 or 3 or 4 pods. And thanks to the work of the OpenShift team, all of a sudden, I've got this much more scaled out deployment with 4 pods running. Well, they're pending, but they will very soon be running. And now if I start Apache benching some more, we'll see the response times go down, and we'll see all of the kind of problems go away. So it's really nice to have this. It's almost like that Autoscale flag that we all dreamt of in years past. Set the Autoscale flag to true. I can literally spin up more architecture right here. And what this is doing is spinning up pods in Kubernetes that run my cloud application and adds this kind of distributed system. Now, of course, with distributed systems comes a whole bunch of different concerns. And as anyone who's ever built a distributed system before knows, things like global variables will not be your friend here. You can't store state in your application. You've got to put it out to some other layer of persistence. Here we have Redis. There's also MongoDB. So there are considerations with scaling things out like this. But it's really nice to have the integration of OpenShift here and be able to scale out my application to more and more pods and watch it scale right here in front of me. So yeah, that is the Red Hat mobile application platform. We've walked through a live demo. We've integrated with a weather service. You'd have to imagine the spectacular degrees in Kelvin appearing in the application because the demo gods were angered. And I'm going to open it up to any questions. Does anybody have any questions for me? Yep.
So as a former Titanium iOS developer, I really, really want to believe you solve the crazy amount of hoops that Apple makes you jump through to publish native apps. Is that really true?
To build native apps, yes. So things like scratching your head about Xcode build errors, somewhat resolved. You don't now need to worry about running a local Xcode install. But when it comes to installing it into the App Store, Yeah, that's still pretty tricky. I don't have an answer for you there. What we do see is a lot of our customers don't submit into a public app store in the first place. They're more likely to use something like an MDM provider, which don't always have like the most user-friendly consoles, by the way. So having that integration there where the app automatically gets pushed is really nice for people. Not a lot of people who'd use this platform do submit into the public app store, but those who do, certainly the build time considerations are much, much simpler. When it comes to actually doing the submission, it's still, there are hoops. Yeah, absolutely.
And the server farm that builds your app for you,
Yep.
is that something that Red Hat hosts?
That is hosted by Red Hat, yeah. The challenge there is that to build iOS apps, you need to run native Apple hardware, and we do run native Apple hardware. In fact, they put these things into a rack because it turns out there's a built-in UPS power supply. It's a laptop, and that's how they achieve that. I think they switched to Mac Pros actually at this point, but yeah, I think the folks that do these hosted Apple things were really sad when they discontinued Xserver.
My question, just to get it clear,
Yep.
once more, to build native Apple apps, you have to have some kind of Mac inside of your network, or is it provided by MBaaS?
It's provided by that core part that you saw earlier, but it is hosted by Red Hat. So we don't have a hosted build farm. What we focus on is hosting the places where kind of sensitive application data flow. But the source code does need to be sent to a hosted build farm, which we will host and provide as a sort of SaaS-like service to you. But that is hosted off-premise, yeah. Yep.
This, I know when it was feed Henry, it originally was cloud hosted. This is something that you can deploy on-premise as well.
It is, and that's quite new, yeah. So that's what the version 4 of the product is this concept of being able to deploy the MBaaS portion on-premise and not have that sensitive data flow outside to another cloud provider. Yep. The core is still hosted in an Amazon Web Services environment. Yep. Any other questions? Yeah? Yeah.
The Node.js backend to make it easy for the app itself. Who is hosting that Node.js service? Well, is it Red Hat? Is it something that you're providing in the cloud?
So it's really up to how the platform is purchased. There's two different deployment models. There's the hosted offering, where what you saw over on the left is hosted by Red Hat, as well as what you see on the right. Or there's the version where this part on the left is deployed within your own infrastructure, hosted by your own operations team. It runs on Openshift, which thus runs on RHEL, if that answers the question. So it's a couple of VMs running RHEL with Openshift installed, and on top of it lives the MBaaS.
Okay, so MBaaS is fine.
Yep, yep. Yep.
Is there any kind of translations of native components like in core builders? Like in Titanium, you write text field turns it into iOS text field.
Yeah. No, so the forms builder is HTML components, and that's what I was dragging and dropping. The idea of taking that and translating it into native code is probably more the space of, as you said, a Titanium or a React Native. I have my own thoughts about that. But I was more than happy to share offline.
And can you customize the CSS like if you want to use?
There's actually a pretty rich themes builder, which I didn't show, so you can build themes for these forms and customize just about everything you can imagine, yeah. All right, well, thanks everyone for coming. Please don't forget about the other mobile sessions during the week. And if you see me wandering around at the conference and want to chat offline about anything I spoke about today, please come up and say hi. I'm friendly. Yeah, thanks everyone.